So as you all know, today's topic by the thumbnail, that is, today we are going to learn about the Dalton's atomic theory and somewhat laws of chemical combinations. The laws includes the laws of indestructibility, or which is also known by the name of law of conservation of mass. The second topic is about the law of reciprocal proportion, and the third and the last one we are going to learn, that is the law of chemical combinations. So without waiting for time, let's begin. So without waiting for a moment, let's begin. Okay, so we are, as discussed earlier, we are going to start first topic, that is Dalton's atomic theory. As we all know that at the end of this 1800 BC, the scientist John Dalton came and proposed a new atomic theory, which is known by the name of the Dalton's atomic theory. Now let us study further deeply in this topic, that what does the Dalton concluded about the atoms. As he concluded about the atoms, this theory is known by the name of the Dalton's atomic theory. So let's begin to learn further. Okay, so firstly he told in his theory that matter is composed of small tiny indivisible particles called atoms. Suppose take this as an example of atom. This is an atom, it is composed of tiny particles. These small particles are known as the tiny particles, which are generally known by the name of atoms. The another point, he concluded that these atoms are identical with respect to its mass, shape and size. Suppose this is the rectangular solid, so it has more number of atoms as compared to the liquid or gases. So as larger the size and mass of the solid, the more the number of atoms. Let me write this. Larger size of size and shape more mass and number of atoms. The another point which he concluded, that the atoms, these small tiny particles, can neither be destroyed nor be created in any chemical or physical process. As we all know that atom is individual particles. So what can we call atom? Atom is this one of the smallest particle which cannot be further divided. Further not divided, which it means that it is undivisible and not be broken into two parts. We can't easily break it into two parts in any chemical or any physical reaction or any chemical or physical process. So did you know what's the size of the atom? Suppose take this as an example of this is an football field, not proper football field, it's its center. So if we put a single cricket ball, suppose this is a cricket ball, green colored, is a cricket ball in the football field, so we can consider this as an atom. What it is an atom. So this is the size of particle of atom. That atom is very small and this is atom, very small, and its radius is also very small, as you can definitely identify by this example as you visualize. So the last point, which was concluded or observed by the John Dalton, is different elements are different in nature. Suppose let us take the example of carbon, C12 12, 6. This is electrically neutral particle, which means it cannot be gain electrons. It can do both, can gain electrons to fulfill its octet or duplet rules, and it can also donate its electrons from its valence shell to complete its duplet rule. And in another side, we can take the example of sodium atom, sodium Na, whose atomic number is 11. So by sodium we can conclude, as you know, that by the experiment, if we, this is water, if we add a single tablet of sodium in water, then only after a single moment of time, the test tube and also the water will explode. This differs the two particles, and as the John Dalton says that different elements are different in nature. So carbon is also different in nature, as well as sodium is also different in nature. And it can be also taken as the example of isotopes, that is hydrogen isotope, hydrogen, deuterium and tritium, H1, H2, H3. So here the topic for the Dalton's atomic theory ends. So let us revise quickly that atom is very small particle which cannot be further divided. Divided cannot be destroyed in nor chemical or any physical process. Different elements are different in nature, and different atoms are identical by their shape, size and mass. Okay, so now let me move towards our another new topic, that's the laws of chemical combinations. As we are very familiar with the laws of chemical combinations, as we are studying from about 8th standard. We also had studied in 9th and 10th standard as well. So it's a common topic, and if you study chemistry or any simple general basic chemistry, then you will definitely going to study this, and it's a very important topic for the structure of atoms. And as you came to know further more or somewhat new about the atoms. So without waiting for a moment, let's start the laws of chemical combinations. So first law is law of conservation. Did you know that this law is also known by the another name, which is known as the law of indestructibility? Indestructibility. As you also know, so what does this law mean? As by the name indestructibility, we can definitely identify that this law is for the indestructibility of atoms. This law suggests that as per as the Dalton's atomic theory, the atom can neither be destroyed or nor created. Nor destroyed. It means that atoms can neither be created nor it can be destroyed in any chemical or any physical reaction, but it can be transferred from one form to another, but cannot be created nor destroyed. So by this one new equation can be concluded that the total mass of reactants will be equal to the total mm, mass of, mass of products as we can know understand by simple example, that is take the hydrogen and chlorine atom. So it will give you so it will form 2 HCl if you balance the reaction. So mass of hydrogen atom is 2 and chlorine atom is 35.5 into 2, that is 71 1 grams. So if we total it, then it becomes 73 grams. And same for here, it also totals 73 grams. So by this we can conclude the above point that total mass of reactants will always be equal to the total mass of products. So, but the one thing that you must be remember is that this law is not applicable for the nuclear reaction. Not the law is not applicable for nuclear reactions, as due to the nuclearity of the elements such as uranium and isotopes of uranium, if it can be lived openly in air, then it definitely will explode and will cause harm to the surround areas and will destruct around 10 to 15 kilometers in radius the area. It destructs the very large huge area. Okay, so let's move further. Okay, so let's move towards the next topic, that is the law of definite proportion. Law of definite proportion. It is also known as the law of which law? Constant composition. Constant composition. What does can you know what did you know what does this law suggest? First of all, you had to know that who has proposed this law. This law has been proposed by scientist Prost. Prost was the Greek scientist who proposed this law of constant composition, or also known by the name of the definite proportion, proposed by Prost. Proposed the above law. So, what does this law suggest? It suggests that a compound obtained from different sources, such as we all know that compound obtains from the two different sources, that is, suppose take the example of compound of water, that is H2 plus O, that forms the H2O. So this is the compound which is formed by the combination of these two elements. Different, or it can be also known as the sources from which this compound obtained. Now the Prost said that the ratio of each component will remain same, that it does not depend on any method of preparation or the source from which it is obtained. It means that ratio, that as you all know that there are two hydrogen atoms, which means the hydrogen is two and oxygen O2 here. So so the atomic number of oxygen is 8, and there are two atoms of oxygen, that is, so it can be concluded that is 16 atoms, so that the ratio for the hydrogen and oxygen is 2 raised to 16, 2 is to 16. It can also be written in simpler form, that is 1 is to 8, 1/8. So this is the ratio, and the ratio will not change in the further for any further compound. Suppose if you take the example of 2H2O, which is also known as sea water, tap water, river water, or any other water such as Ganga Jal, or any water we can take as example, but the ratio will always remain 1:8 for every compound of water. If there is 2H2O or a single H2O, any number of molecules, the ratio will always remain same, that is 1:8. Ratio will not change. It must always be remembered. And ratio will not change, of which the ratio will not change of the compound from which it is obtained. Suppose if the water molecule is obtained from hydrogen and oxygen molecules, so if you do the preparation in lab for the H2O by any method, the ratio will always be 1:8. It will never going to change. So if you got whatever as a product, suppose if you got 2H2O, then also the ratio will always 1:8. It will not change. Okay, so let's end today's video, and in next video we are going to discuss about the law of reciprocal and law of law of multiple proportion. For today's lecture, this much only, and if you have any doubt, then you can definitely ask in the comment section or in the Instagram, as I will provide my Instagram account link in the description. So please like, share and subscribe my channel and follow me on Instagram. For any doubts, I will definitely reply you. So thanks once again. So I guess I hope that you all have enjoyed the video very much, and so let us revise simply whatever we have studied in the video which I have provided you before, which we have just completed. So first we learn about the Dalton chapter theory, and there are 4 points of the Dalton chapter theory which are that first is atoms can neither be obtained nor be destroyed in any chemical or physical reaction. Second, atoms nature of the atom depends on its size and atomic weight or its number of elements or mass and of size. The last point which we discuss is that the atoms can neither be created nor be destroyed. Another point that is as well, it is very small, and the size, as I discussed earlier, the size of the cricket ball, that's the center of the football field. So after that we learn the laws of chemical combination. The first is the law of conservation of mass, which we also going to discuss. This is also in the indestructibility, which is indestructible. So that law means the law says this atoms 73 gram on the mass on the product side. But the main point we forgot to discuss here is that the law of indestructibility is not applicable for any